Hi, my name is Katie Mutafis, and my partner's name is Jake Durkowski, and our final project for Dr. Glisson's information security class focuses on the application Zoom and its security flaws. So if you don't know already, Zoom is a popular video conferencing platform, and it became exponentially popular due to the COVID-19 pandemic, with schools and workplaces following stay-at-home guidelines. With this popularity, Zoom actually became the center of attention for both white and black hat hackers. So one of Zoom's claim to fame as well is that it uses end-to-end encryption for all of its communications. And that means we're safe, right? But we'll explore this aspect of Zoom later on. So for now, our focus is going to be on some interesting exploits. So what is Zoom bombing? Zoom bombing is when an unauthorized individual gains access to a Zoom meeting and hijacks the controls, such as screen sharing, webcams, chats, etc. There's really no limitation on what they can take control of, and it's kind of scary. So how do they do this? One of the ways that they can do this is via a UNC path. They can use this path to drop payloads that take control of the screen or webcam, but it can also be used to steal Windows login credentials, which is what we're actually going to focus on in our experiment. So if you've never seen a UNC path, those paths that start with 2 slashes, and we'll show you in the video that's about to come up, but it's a standard for identifying network resources. And so Windows does this really awesome thing where it tries to automatically authenticate to an SMB server at that specified path by sending your Windows username and password hash. Sounds great, right? But Zoom automatically rendered these links as clickable within the chat feature of their application. So usually if a link is rendered as clickable, most people don't think twice about clicking on it. And this is actually a very recent thing that Zoom has patched. They patched it as of April 2nd, 2020, I think is what the actual date was. So it's pretty new.
This is a video demonstration of the UNC vulnerability that has been found in Zoom. To demonstrate this, we will be using a Kali virtual machine and a Windows 10 virtual machine. Kali machine will serve as the host of the meeting, where the Windows 10 machine will be the guest. So from the Kali machine, we're going to begin a meeting that we have already scheduled and where we have already sent an invitation to the Windows machine. So once the meeting is up and running, we're gonna ask to join it from the Windows machine, and the meeting information is in that little notepad which came from the invitation. So when we ask to join, we're going to be held in a waiting room, which we'll get a notification here. While they're in the waiting room, we're going to take this opportunity to go ahead and run the responder program. This program is a packet poisoner, and it also creates multiple different servers that are used to take advantage of the poison packets. So this highlighted IP address is the IP address in which we're going to be listening or receiving all of the poison packets from. So now we have the listener up and running, and we've just admitted the guest to the meeting. So now it's time to establish some type of dialogue between the host and the guest. The dialogue that I have created is where the host is the instructor or boss or whoever who's leading the meeting. They failed to post whatever documents that are going to be discussed for the meeting. But they didn't forget. In this specific case, there was no documents to be posted. However, we're going to use this dialog to show that we're going to send all the guests in the meeting a link to download the documents that they're requesting. However, this is not going to be like a Google Drive or a link of that sort. It's going to be a UNC link, which stands for the Uniform Naming Convention. And as you can see, the link that we will send is the IP address that was recently selected or highlighted in the terminal. So we begin it with 2 backslashes, IP address, and then some arbitrary set of characters or numbers. The name of the quote file is irrelevant. If anything, it's more important for it to not be an actual file, which in this case it will not be, because the file structure on Linux systems do not follow this structure at all. So we don't have to worry about that. But as you can see in this particular version of Zoom, whenever we send this, it appears as a link. Whenever the guest goes to click on it is when we produce a lot of results. And in the case of the Windows machine, a lot of unwanted results. So as you can see here, this is the same terminal where we ran a responder. We've poisoned on these different channels. But then when we go back to the Windows machine and we actually click on the link is when we get our desired outcome. Here it displays a whole bunch of information about the guest, including the IP address, username, and most importantly, the hash of the user's login credentials. And then I just kind of finished it up in the most appropriate way possible. From this point, none of that was necessary, but we go back to the terminal in which we listened and received the NTLM hash from, and we want to save that hash into a file so that we can later crack it. And there you have it. We have successfully captured the user hash, and we can now continue to crack in their password. Once we have successfully captured and saved the hash into a text file, we will be using the program called Hashcat in the attempt of cracking it. The command that we will be using is hashcat tag m5600. This 5600 tells Hashcat the mode that we needed to run in. This mode is specifically designed for the Windows NTLM version 2 hash, which is their common methodology or current methodology that they're using to store their passwords. Now this process can take a while. It just is dependent on the security of the password and the word list that is being used. As shown, this particular example did not take long at all. Here are the statistics of this crack along with the equivalent password for the imported hash. Therefore, this crack was completed successfully. To get a better understanding of what was happening throughout this attack, we ran Wireshark in the background and in the hopes to find any nuanced data or anything that would be viable to this research. We also wanted to try to determine the types, if any, encryption is used between the Zoom servers and its guests. Here we can see that whenever the guest is joining the meeting, a TLS handshake occurs and establishes the method of key exchange that is to be used. Diffie-Hellman is the method that it uses, as we can see from the details of this packet. And once this exchange has been made, the packets going to and from the guests and the Zoom servers are now encrypted, as you can see in the bottom of the second image. Here's where it gets a little bit more interesting. The top image shows the request for the WPAD file from the Windows machine being sent to the Kali machine. This is where all the useful information that we have found lies, including the password hash and the information about the user. And the reason why this information was able to be gained is because a lot of these requests are to servers that that do not exist, calling or making it almost of a recursive call, which ultimately leads to the dumping of the user's NTLM hash to the Kali machine. The second image just shows some of the particular packets that were poisoned by Responder. And it's important to note that this information that we have gotten from this research is only made possible because of the Responder program, which initially poisons all of the packets and allows them to be redirected to the Kali machine and allows the information that we have gotten from these packets to be available. This is a particular packet that was captured, which contains the user information. Here we can see that the domain of the user, the username, and the host name. Just to put pieces together here, this is Zoom user 1, which is also the same user that we targeted in the video, and this is also the hash that we received from that user, which is the NTLM response.
So shortly after we did this exploit, Zoom patched it. It rendered any link, valid or not, as unclickable. This did not allow us to do any type of link redirection at all. However, their fix, quote unquote, does not prevent somebody from copying and pasting the link into their browser, as we demonstrated in class. Jake and I were actually really surprised at how many students asked us why the link that we sent during our Zoom meeting for class didn't work. So after we did the upgrade, this experiment no longer worked, and we tried variations on the UNC path injections to try and break the patch, including a UNC path traversal, which you basically just hide the UNC path in a regular link, poison Word documents. So I tried to insert a video that pointed to the UNC path, so when somebody opened the Word document, it would automatically try to load the video from the attacker's machine, even though it doesn't exist. And I also figured out how to modify the frame set of the Word document using 7-zip, and that did not work. And Jake tried to embed the link into an image via StegoSuite, which that did not work as well. We were unsuccessful at grabbing the username and password hash. So again, like I said, Zoom's patch does not prevent anybody from copying and pasting the link into their browser. So the way that Zoom should handle sending UNC paths is the same way that Discord does it. Jake and I actually figured this out when we were talking about our project on Discord. We would type a UNC path in the chat bar with the 2 slashes in front of it, and then when we hit enter, it would automatically get rid of one of the leading slashes. So this prevents anyone from copying and pasting the link into their browser and having it go somewhere malicious. Another thing that you can do to protect yourself is disable LLMNR and NBTNS. So the way you do that is you open your local group policy editor on your machine if you're running Windows, and then you enable turn off multicast name resolution. Now that sounds kind of backwards, but you don't want multicast name resolution, and Windows automatically has that turned on, so you want to turn it off. Another thing you can do is turn off your automatic proxy server, and the way you do this is you open your network and internet settings, click proxy, turn off your automatically detect setting. Again, Windows automatically has this turned on because I don't really know why. I haven't really found much on why these settings need to be enabled, but it is what it is. So another thing about Zoom that we really wanted to talk about to drive our point home that we should not use Zoom is that Zoom claims to use end-to-end encryption, which great, end-to-end encryption is great. So most people understand end-to-end to be a form of encrypted communication in which only the communicating parties can view the messages being transmitted. So this means that internet service providers, intruders, and even the communication service provider itself, in this case Zoom, cannot view the messages being transmitted. We actually found a few studies that people at other universities have done that show Zoom clients have end-to-end encryption with the Zoom servers, but within the Zoom server itself, Zoom can have access to your unencrypted data. Zoom has publicly said that they do not look at anybody's data, but the point is that they could if they wanted to, which is really scary, especially because it's been found that some servers are actually in China. So we have some servers going overseas, and so your data can be overseas. Their encryption scheme is also not super great. According to their documentation, data is transmitted via UDP and encrypted using AES-256 in ECB mode. AES-256, great, that's awesome, but ECB mode is not great. So ECB stands for Electronic Codebook, and basically the way this mode works is that identical plaintext blocks encrypt identical ciphertext blocks, which can lead some hackers to get clues about your data. Upon researching this, I found this image kept popping up everywhere I was looking. The ECB penguin, you can Google it and this image will pop up. So on the left we have the original penguin. In the middle, we have the penguin encrypted using ECB mode. Now, as you can see from the leftmost image to the middle image, you can still tell it's a penguin because, again, the identical plain text blocks encrypt to identical ciphertext blocks. So you're going to want to use another mode of the AES-256 in order to make this more secure and generate pseudo-randomness. So our solution is Zoom is a very useful tool given the current circumstances of the world. So Zoom is a great free tool to do online web conferencing for schools, work, pretty much any large group. If you want to talk to your friends, it's great because it's free. However, with its growing popularity, it's only a matter of time before another hacker finds another vulnerability. And we saw this with our experiment is we found the vulnerability and then a day later somebody patched it. So that's kind of how this works, but I feel like the hackers are racing to find a new vulnerability before it gets patched. And these are actually not the only vulnerabilities that we found that exist. We've found that you can run programs on somebody else's computer using Zoom. You can take control of screen sharing. You can take control of somebody's webcam and install spyware, all kinds of stuff. And it's very, very scary. So we would recommend that you use a different application for your web conferencing needs. Cisco WebEx is a great one. GoToMeeting is another great one. These are not free tools. However, with how insecure and scary Zoom is after we did this project, I would recommend paying the extra money just so that we all remain secure. Thank you guys for listening, and I hope you guys have a great rest of your day.